Alright, in this section we're going to be looking at areas of circles, and we'll also be looking at areas of their sectors, which are going to be parts of them. So we should already know the area of the circle as pi r squared. But the next thing is the area of a sector, and a sector is when we take a part of a circle where we're going from the center, a couple of radii, and then the part that it cuts off. Now notice this is just a fraction of the circle, so our formula is taking the area of our circle, or the pi r squared, and multiplying it by the fraction that we have. To find that fraction, we'll take the central angle and divide by 360 degrees. For example, if I have a circle whose central angle is 90 degrees, that would be 90 over 360, or 1/4 of our circle. So we would just take 1/4 of our area to get the area of that sector. Or if I had a 120 degree angle in the middle, that would look something like this. And that 120 divided by 360 will give me 1/3. So this area would be 1/3 of the whole area of the circle. So here's a problem where we have an arc of 72 degrees. Remember, our definition of an arc measure would mean that the central angle is also 72 degrees. And so the area of this sector would be, we would take our angle of 72 degrees to find out what fraction of the circle we have, and then we're going to multiply it by the area of the whole circle, which is pi r squared. Our radius being 15, so 15 squared. Working that out, that's going to come to 45 pi. They asked us to leave this in terms of pi, and so we're not going to multiply that out, but we are going to include our units of centimeters squared. Next we'll look at a segment of a circle. Now a segment of a circle would be if we take a chord and cut off part of a circle. And notice we could look at that as though we have the area of the sector. Taking that chord, if we subtract away this triangle here, then that would leave us with the segment of the circle. So we'll use the formula for the area of the sector that we just saw, where we take our angle, our central angle, and divide it by 360, and then we multiply that by the area of the circle, or pi r squared. For the area of the triangle, there might be other different ways to do it, but probably the easiest way is to think about this is the radius, and we already know our central angle. So we're going to use the formula for area that involves sine, where we use 1/2 a times b times the sine of c, or the angle included between them. Now in this case, since we'll be using the radius for both a and b, so this will be like r times r, or r squared times the sine of our central angle. Notice we'll be using the same angle in both parts. And if we work each of those out, subtract them, we're going to get the area of the segment. So here's an example here. Let's do this in parts. Let's start with the area of our sector, which will be, notice the angle here, the central angle is 60 degrees over 360, or 1/6, times the area of the whole circle, using pi r squared, or pi times 18 squared. And we want our answer to the nearest tenth, so I'm going to go ahead and just plug everything into my calculator, including the pi, and get 169.646. Now I'm leaving extra decimals so that my final answer will be accurate. Next we're going to look at the area of the triangle. Okay, so this part here, we're subtracting that away. And again, we're using the formula 1/2 a times b. Now since this is 18, that would be my a. My b would also be 18 because it's a radius, so these two are congruent, so also 18. And then times the sine of our angle between those two measurements, which is 60 degrees. And that will come to 140.296. So we have the area of this whole part, the sector. We now have the area of the triangle, so we want to subtract those to find the area of the segment. And rounding to the nearest tenth, we get about 29.4 square inches. Be sure to include units if they're given to you.